Students, in this problem, the load is given is eccentric. So whole numerical is belong to eccentric loading theory. A load of 25 kilonewton is acting at the end of C clamp, having rectangle cross section. Eccentric distance is given in horizontal distance is 150 millimeter. Determine the dimension of cross section. The height is given 2 times its width, and the permissible stress is given 100 Newton per mm square. So let's first draw a sleek C clamp. Okay, now you understand how it works. When you try to clamp it, it's going to create a force down on a given product. Okay, so because of that, it is going to subjected or going to experience a reverse loading in vertical directions. Now what happened, that vertical reaction is equal to 25 kilonewton, and hence whole C clamp is tried to bend in this manner because of given loading conditions. Now because of this, there are two types of stresses are acting. One is direct stresses, second is bending stresses. Now direct stresses is simply given a cross section. Okay, you can directly consider on a given cross section. So this is height and this is B. Okay, now because the load acting at a distance of 150 millimeter, or you can say the loading is eccentric, and hence it result in bending. Okay, now we have learned in the theory of pure bending, because of this kind of bending action, there are going to be a tensile stresses and as well as compressive stresses set up in a given section based on in which direction it bends. Here, if you consider a cross section 1 over here and the section 2 over here, and because of that, the tensile stress is going to set up at section 1 and the compressive stress is going to set up at section 2 along with the applied direct stress. So here you can say, if you consider the direct stress in upward direction, so at section 1 the direct stress plus bending stress get added, but at section 2, as per the eccentric loading theory, because the compressive stress is in downward direction having opposite direction, so the total stress will be direct stress minus bending stress. Okay, so from these two concept of eccentric loading, we can say the maximum stress is going to occur at definitely at section 1. So let's find the maximum stress. Maximum stress is going to occur at section 1, which is given as 100 value as a safe limit. So we are going to write it like this way: direct stress divided by bending stress. Now direct stress is simply P by A, and the bending stress is nothing, P into its distance divided by section modulus Z. Now let's say, let's simplify the equation sigma max with the value given. Load is 25 kilonewton divided by cross section, which is H by B in direct case, and for bending value it is 25,000 Newton into 150 millimeter distance, eccentric distance, and the section modulus Z. Here we are going to consider as, let me explain what is section modulus Z. It's a ratio of moment of inertia divided by maximum distance. Okay, in our case it is rectangle section and load is acting in this direction, upward direction, hence it is trying to bend in this way, right? So this is our reference axis. Now we are keeping horizontal distance in upward direction and the width dimension in horizontal direction. So we have to take moment of inertia I is equal to 1 by 12 bh cube. Now let's calculate Z. Z is nothing, it's a ratio of I by Y. So let me replace the value 1 by 12 bh cube divided by the section distance in which the maximum bending stress is developed, right? Now from the pure bending theory, we know the bending stress is maximum at the outermost layer. So here from the neutral axis, the outermost layer is basically half of the distance. So I am going to take h by 2, section modulus Z 1 by 6 bh square. So let put value over here bh square. Now let's replace the relation given for the h value. Now here 25,000, let's replace h equal to 2b, so 2b square plus, here let's take the 6 in upward term, 25,000 multiplied by 150 into 6 b into 2b square. Now let's simplify the equation. It's going to be 2500. Second time it's going to be 562500 divided by, you can say, b cube. Okay. Now the maximum safe stress is given 100. So let's replace that value. So 100 12500 divided by b square plus 562500 divided by b cube. Now let's divide both the side by 100 value. So here it going to be, left part going to be 1 and this part going to be 125 b square plus, let's see what is given, 56250 divided by b cube. So we can write like this: divide both side by 100. Let's multiply this equation by b cube on both sides. So b cube 125b plus 56250. Okay. Now let's simplify this equation. 125b minus 56250. Okay. Now here we have to find out the value of b from this equation. Now using trial and error method. Now let's try to understand what is meaning of trial and error method. Using trial and error method, we can find a solution of these equations. For the b value, what this equation say? For the b value, if you place over here, this equation must be comes out to be equal to 0. So we have to find out the value of b such that it makes left hand side of this equation 0. So let me draw a timeline over here. So I want to find out b. When I replace in the equation, it gives you 0 value as a solution. Okay. So let's assume first value. Let me assume b is equal to 50 millimeter. Now what is left hand side? Let me calculate using calculator. So it comes out to be 62500. So for when you take b is equal to 50 millimeter, you are end up with the positive value of 62500. Now let's reduce the value. Let's reduce the value by say 36. Okay. Now what is the value of left hand side? Let's calculate it. The answer is minus 14094. So for assume value of 36, we are having left hand side value of equation is minus 14094. Now what does it mean? It is very clear that the b value is lying between these two values, for which the left hand side equation will be 0. Okay, so we are going to take an average of these two. The average will be 43. Okay, so let's take first 42 value and check it. What is left hand side? It comes out positive value. Okay, so you can say for b is equal to, when you take b is equal to 42, the left hand side is comes out to be positive value of 17,000. Okay, now here from this timeline you can say again the b value will be the average of these two, 36 and 42. Now we have to cancel out this b is equal to 50 value because it is out of range. Only average of these two value, 36 and 42, will give you the nearest value that result in equation of, or left hand side of the equation equal to 0. Okay, so average of these two, you can say it is 4 and 6 39. Okay, so let me take b is equal to 39 and let me find left hand side. So always by taking the average closer to the 0, you will end up with the right value. This is called trial and error methods. Put the value of 39. The solution is minus 106. Okay. So you can say the for b is equal to 39, I am getting 1806. Okay. Now here, let's take the average of this 39 and 42, or let me simply take a 40 value. So left hand side will be actually the average will be different, 39 plus 42 divided by 2. So the difference is 40, 41. So it's going to be 40.5 something, right? But I am taking 40, so I can reach to the solution. So 2750. If I have taken 40.5, definitely this value going to be higher side. So again, let's say here for b is equal to 40, the left hand side is comes out to be 2750. Or let me write over here, it is 2750. Now from these two values, either 39 and 49, you have to decide which one is closer. So you can say that this 39 is very close value, but 39 is odd value. So we can say that b is equal to 40 is the right answer, because 40 will give you 1 more millimeter material on a section to resist the given load. So the right answer is 40. So b is equal to 40 millimeter, and the height is 2 times of b, which is 80 millimeter. Now this is called trial and error method. This way you can find the cross section of eccentric loaded C clamp. I hope that you have understand the trial and error method.